Hello and welcome. So this is going to be our follow-up video on practicing my personal favorite method for solving systems of equations, the elimination method. Now in the notes we saw basic eliminating problems where the question was already primed to eliminate. Then we saw how we could fix one equation so that it could be ready to eliminate. And at the bottom of this practice, we're going to see a abysmal example that's going to need a lot of fixing before we can use the elimination method. So let's get to it, and here we go. Example 1. Again, we're looking for our equal and opposite pairs. So I notice I have a plus 10x minus 10x. That means it's ready to eliminate. So there you go. 6 minus 2 gives you 4y's. And when I add these two negatives together, it actually gets more negative. That means I will have negative 36. Dividing both sides by 4 tells me that y is in fact minus 9. Again, to find the second variable, you take whatever you found first and you plug it back into one of the equations. I like the second equation. You could still use the first, that's okay. I say this probably about every time I do a problem, hoping that you guys know it doesn't really matter at all. So 10x plus 6 times negative, 9. Can't even read my own handwriting there. Negative 9 equals negative 14. That will give me 10x minus 54 equals minus 14. Scroll, scroll, scroll. Plus 54 to both sides. Works some magic. 10x equals 40, so that means x is also 4. So now we know that we are done with this question because we have solved for x and y. Typically we got two whole numbers, which because I engineered the problem this way, it lets us know we're on the right track. Just so you guys know, decimals can happen. I mean, they can happen, but as math teachers, we prefer whole numbers. That's not to say that we don't throw decimals in there sometimes, but it causes a lot of students to freak out for some reason. Okay, second example, moving on. This one is again ready to eliminate, and the x's eliminate because we have plus or minus 5x. This y right here is the same as 1y, so if I do 1y minus 4y's, that tells me I have minus 3y's. And again, we're still adding, so if I were to add 27 and negative 18, that's just like subtracting the 18. Okay, make sure to divide everything by negative 3. Coincidentally, y is negative 3. That just happens. And last time I plugged it into the second equation. Let's plug it into the first equation because, again, it does not matter. Minus 5x minus 4 times minus 3 equals 27. Negative times negative gives us that positive 12. I need to subtract 12 from both sides. Negative 5x equals 15. Dividing by negative 5 tells me that x is also negative 3. So we got a lot of negative 3's in this problem. That's just the way the cookie crumbles. Okay. So if I'm going through this too fast for some of you guys, go back, pause the video, and take a look at the first video. These are all things that you can do to help you out. Alright, the third example. So as I was saying, these two examples are not ready to eliminate. And if I try to add them, look at what happens. Minus 7x plus 4y, who cares? Because none of the variables eliminated here. In elimination method, we want that to happen every single time. So we're looking for that positive and negative equal pair. Well, the y's are both positive, so it's going to be easier to change my x's. I could have a positive and negative 14x if I multiplied the bottom equation by 2, because 7 times 2 gives us 14. So great, I'm going to write down the top equation because that one was nice, and I'm going to multiply everything in the bottom equation by 2, and don't forget to double that 20 to get 40. Now it is ready to eliminate. So our x's eliminate, 7y equals 63. Dividing both of those by 7 gives us y is equal to 9. And again, to find out what your first variable is, in this case x, we're going to plug it back into one of the equations and solve for it. So I'm going to use the first equation right here, negative 14x plus 9, I substituted in, equals 23. I will need to take away 9 from both sides. So negative 14x equals 14. This time I'm going to show the division step because it's non-trivial. And we get that x is equal to minus 1. So in this problem, we had to fix one of our variables because the equations did not match up perfectly with that plus-minus pair. But after multiplying it by 2, I got that plus or minus 14 that I wanted. Now in a class, someone said something very clever where I said, what would we need to do to fix this? And the student said, well, we can multiply by 1.5 because I know that 2 times 1.5 gives you 3. And that was a pretty clever thing to do. However, I want to discourage that for one reason. Introducing decimals is gonna make room for more errors in the future. And it would be much simpler to change 2 equations with whole numbers than it would be to change 1 equation with a decimal. So for instance, because I can't use a whole number to turn a 3 into a 2 or a 4 into a 7, I'm going to look for a common multiple. So yeah, 3 and 2 have a common multiple. That multiple is 6. So if I multiply this by 3 and that by 2, I'll get my common multiple of 6. But the issue is when I add them, I'm going to get 6 plus 6, which is 12. That's not eliminating. So I'm going to need one of these to be negative. If I make the bottom equation negative, then I'll get a minus 6x, and that way they will add together and give me no x's. So on top, I'm going to distribute by 2. 6x plus 8y equals negative 52. On the bottom, I'm going to distribute by minus 3. Minus 6x, yes, minus 21y equals, alright, now we got to multiply this by 3, negative times negative, that's going to be 78. There you go. Time to add them up. X's go away. Be careful with this positive negative right here. This will give us negative 13y. And if I add these two together, I will get 26. Well, that's great because 13 is a multiple of 26. That tells me that y is going to be negative 2. And just like all of the problems that we've done previously, once we have one variable, we're going to plug it back in to find the second one. So now what I'm going to do is I'm going to take that first equation and I'm going to plug in y equals negative 2 right there. So 3x minus 8 equals minus 26 because in my head I did 4 times minus 2, which gave me minus 8. Add 8 to both sides. 3x equals, wait a second, oh, thought I made a mistake. Did not, okay. Equals minus 18, divide by 3, x is equal to minus 6. So yes, this practice went a little bit faster. That's because I took my dear sweet time going through the notes earlier, so if you still feel a little unclear about this process, go back and rewatch the first video. But the elimination method does not get harder in a sense. Really, you just need to choose the correct multiple to fix your problem, and then everything's good to go. You add them together, you get one variable alone, and you plug it back in, which is a process that we should start to feel a little bit more familiar with. Let me know if this was helpful in the comments, and I will talk to you all later.